Then whether it is 1 or 0. Both are 24th. They are both on the same network segment. I forgot to write a space here. Reconfigure 192.168.0.100. Okay. The two of them are actually on the same network segment. All in the 192.168.0.0 network segment. Then we configure the network segment. You can check it out here on PC too. Now I have not configured a gateway for it. That is. Now gateway is empty here. I only configured an IP address and mask. Gateway not configured. Gateway is empty. Then for PC3. I did not configure the gateway. This means that if data access across network segments, I can't access. So now we go into the router. Enter this interface. We configure it accordingly. This will be slightly slower. We enter configuration mode. Then enter the interface. The one on the left is the 00 interface. We configure an IP address. It is 192.168.1.254. Then we configure the mask. 3255 and 10. Because it is a 24-bit mask. Followed by no shutdown. Enter the 01 interface. We also configure an IP address for it. It is 192.168.0.254. The mask is also 3255 and 10. We also give it no shutdown. It is now configured. Let's walk through the process. As a PC. Let's see what it should do now. Before that, we still have to capture packets. But I turned off other environments before. Because this is the previous configuration. When we captured on the left and right interfaces of R1. First look at the 0 interface on the left. After that, it is also opened here on interface 1. That is, we now capture one interface. Open both. After we open it, let's go on. For the current experimental environment, let's think about the process. First ask everyone. If the left PC pings the right PC, can you ping through? What we say now. This is the 0.0 network segment. This is also the 0.0 network segment. Both are on the same network segment. If the PC now judges that the other party is on the same network segment as itself, it should send ARP broadcast directly to the other party. Query the other party's MAC. For example, before the PC wants to ping each other. To encapsulate the second layer. I don't know the other party's MAC now. The PC must first send an ARP packet to ask MAC. But the embarrassing thing is, they are indeed on the same network segment. And for routers, the left interface is the 192.168.1.0 network segment. The right interface is the 192.168.0.0 network segment. The two interfaces of the router. Not in a network segment. But for PC. Overall. Can be on the same network segment. For PC1. They are on the same network segment. For PC2. They are on the same network segment. But for routers. These are two interfaces. Now you will find the overall network bit of the two PCs is too short, causing them to cover a larger range of network segments. But for routers, network bits are too small, causing them to have too narrow a segment range. You will find, in theory, they are both right. They are both in the same network segment. These two are in the same network segment. And for the router, these are two network segments. We don't talk about switches. A switch in the middle. This is the same as a missing switch. Both of them cannot be pinged. We just said PC2 sends an ARP broadcast to ask. But unfortunately, ARP broadcasts can only be forwarded under one broadcast domain for the interface of the router. Each interface is a broadcast domain. That is, now this message can only send to this location at most. This ARP request cannot be sent to the other side. Let's test it first. It is now 192.168.1.100. Ping 192.168.0.100. Let's take a look. We can find out that it seems to work. In theory, it should be unreasonable. How come it works again now? That's another question. First of all, for the router. Let's first look at the left interface of the router. Everyone will find indeed received ARP packet. I stopped it. Don't worry about the other ones, what they are. What is asked in this ARP packet is, who has 192.168.0.100? Call 192.168.1.100. 1.100 is the PC on the left. 0.100 is the PC on the right. I cut this picture. Look at. Because we follow the message. To analyze it will be more accurate. Let's look at this picture. Now PC3 is 0.100. PC2 is asking PC3. Then now you will find the device got a reply. There is now an ARP. This is called ARP request. Is a request message. The following is called ARP reply. Is a reply. Now it receives a response. And it got the MAC address of 0.100. That is, it gets the MAC of the right PC. Let's take a look. Is this MAC the MAC of the PC on the right? We go into this PC3. Check its MAC address. We will find this is not the MAC address of PC3. PC3 is 005079666803. It now replies with AABBCC001000. It's not a PC3 MAC. In the process, it goes to request PC3. But PC3 did not reply to PC2. But it does get a MAC address like PC3. So whose MAC address is it? It must be real. Now the left PC is requesting the MAC of the right PC. It did get a reply. Now the MAC corresponding to the PC on the right is AABBCC. But we looked at the device's MAC. Found that it is not the MAC address. So, whose MAC address is this AABBCC? Okay. Is the 00 interface of the router. In fact, we don't have any other interface now. A total of 4 addresses. Both of them ruled out. Now there are only 2 of them left. It feels like this address. Because the MAC address works on a link. So is the address of this interface. So it replies pretending to be PC3. Let's check the current interface of the router. We have to get out first. For example, I am now checking a layer 2 interface. I'm going to see Ethernet. It is the 00 interface. Let's see what's written here. Address is AABBCC001000. This looks familiar. This is the 0 bar 0 interface on R1. It's a MAC address. This is what we are answering now. AABBCC. That is,